Okay, so today's lecture is about the fundamentals of switching theory. Specifically, dun muna tayo sa pinaka-logic itself. Kasi ito yung pinaka-basis sa mga future circuits natin na gagawin sa course na ito. So, we'll start off with defining yung digital systems. Most of those systems na pinag-usapan natin ng LX2, for example, meron tayo op-amp, di ba? Mga op-amp na naka-gain configuration na pag ganito. So, ayan. Okay? So, remember that these op-amps configurations, yung pinaka-output nila is some different voltage kumpara sa pinakasimula. Right? And mostly kasi, itong mga systems na to, okay, they are analog systems. So, when we say analog, they vary continuously with time. Okay? Or in other words, hindi sila discrete. So when we say discrete, it means na usually there are some specific values lang na tolerable, no? So for example, dito, we say 26 letters in the alphabet. So meaning, sa alphabet natin, meron ng 26 letters. Okay? So wala nang iba pang dadagdag. Unlike, for example, dito, yung voltage nitong VO na to, it can be from 1 to 5 volts, okay? Pero kahit na 1 to 5 volts siya, alam natin na may mga numbers in between that, kahit dun pa lang sa 1 volt to 2 volts, this is already analog. Kasi we know na meron tayong mga decimal sa pinakaloob, 1.111, dagdagan mo pa ng 1 yan, hanggang sa maging infinite yan na ones. So that's why siya naging tinatawag na analog. So unlike in an analog system, in digital systems, yung mga data natin rather, they are in discrete amounts. So for example, kapag sinabi lang na 10 decimal digits, there are only 10 possible values, 0 to 9. Okay? And yung mga binary numbers, or rather yung pinakaunang digital system na pag-uusapan natin is yung binary system. Okay? So when you say binary, okay, ito pala. So binary numbers or binary system are made up of binary digits. So this is why each data sa isang binary system is a bit. It's called a bit. So when you say na, for example, yung number, let's say yung number na 101 in binary, okay? Each place here is called a bit. Okay? Pag nagkaroon ka ng isa, so now you have 4 bits. So 4 bits itself, it's now called a nibble. Nibble. Likewise, kapag, oh, wait lang. Ayan. So likewise, kapag nagkaroon ako ng isa pa, 1011 ulit, right? So now we have 2 nibbles. Now, ang gawin natin, pagsamahin natin silang dalawa. So this whole number here, isang buong number na to, so this whole number is called a byte. So again, the hierarchy is bits muna. So 4 bits will become a nibble. Nibble. And afterwards, kapag may dalawang nibble ka na pinagsabay, you have a byte. Or in each case, it's actually 8 bits. So that's why makakakita ka ng mga laro na 8-bit na laro. And you'll notice na pixelated sila. Yung isang byte kasi na yun, so makikita mo sa mga files natin, we have 1 kilobyte. Ayan, for example, 1 kilobyte. So that is equal to 1,000 na bytes. Meaning there are a total of 8,000 bits of data for that. Okay? And that 1 pixel usually is 1 byte, no? Or depende sa pinaka ano din. So like, alam naman natin na pag meron kang isang pixel, meron kang ibang kulay, gaano siya ka-shape, and then of course, iba-ibang kulay, syempre for that type of shape. So basically, that 1 pixel conveys a lot of information. So meaning that 1 pixel could be more than 1 kilobyte. So that is why yun yung pinaka basis ng binary system natin. Now, bakit ba usually tayo nagwo-work with binary system kung alam naman natin na ones or zeros lang yan, you know? Kapag isang circuit, it's either naka-off siya or naka-on lang siya, right? So, bakit need natin maggamit niyan? So, number one daw, easy to represent daw kasi ang isang circuit using zeros and ones. And ayun na nga, it's simple. Kung zero siya, off lang siya. Kung one siya, on lang siya. That's good. Pero paano natin magagawa na kapag iba-iba na yung values? Well, meron naman tayong mga digital to analog na mga converters. Okay? So, bakit din natin need siya i-convert to digital muna bago natin i-convert to analog? Well, meron kasing next na reason dyan, and that is, it is possible to tolerate noise. So, what does this second statement mean? Ganito kasi ibig sabihin yan. Kunyari, meron kang isang meron kang isang op amp na ganito yung configuration niya. Okay, so let's say you have an op amp of this configuration. It doesn't matter na kung ano pa yung tingin mo dyan, alright? Just know that this is an op amp. And you wanna know the output niya sa VO. So ito yung magiging itsura ng VO niya. Okay, so this is what it looks like. Now, anong manonotice nyo? What you'll notice is that usually meron siyang pinaka-smooth na output, right? Usually ganito yung itsura ng smooth output niya, ganyan. If we could redraw the signal, this is what it's supposed to look like. But hindi. Instead, ang itsura niya is that iba-iba siya ng value. This is of course what we know as noise. So noise changes the value of a wave. Specifically, ganito yung itsura niya. Okay? And the problem with that is that kahit yung ganoon kaliit na change sa value ng output, it could have detrimental effects sa iyong circuit. So, anong pinaka ginagawa nila dyan para maging ganito yung itsura niya? Ang ginagawa nila dyan is that kino-convert nila ito into digital. Anong pinaka simplest way of doing that? Well, the simplest way of doing this is usually, wait, delete na natin ito. Okay. So the simplest way of doing this is through a comparator. Okay? Ayan. So hindi na discuss to kay Sergi. So ako na lang magdi-discuss muna. Okay? So we have what we know as the comparator. I think it was the other way around. Okay. Ayan. Okay. So this is the comparator. So anong ginagawa nitong comparator na to? The comparator is simple. It's an op-amp na walang mga walang mga ganitong resistors. Meaning, you are only putting input to the op-amp itself at wala siyang feedback na ibabalik. So the reason why you're going to do this is because the idea of an op-amp is that if yung VI mo, or V plus mo rather, okay, meaning your non-inverting input mo, it is greater than your V minus, the output of your VO is equal to VCC. Okay? VCC, that is itong ginagamit mo dito, no? Ito yung VCC. Or in our case, no, it is simply just yung value 1. Okay? In binary. So likewise, kapag yung V plus naman is lesser than V minus, then your VO is simply equal to 0. Okay? So if we were to evaluate this wave, ang gawin natin is let us mark the parts na nagka-cross siya na 0 or exactly nasa 0 siya. So ito yung mga points na to. Okay? They cross the 0 points. Ayan. Okay. And here, we're going to put, hindi pala ganito. Kahit ito na lang pala. Ayan. Okay. So this will be your 0 volts and this will become your VCC. Okay? Ayan. So ganito daw ang sinabi. Kapag yung input mo daw is greater than your V minus or your non-inverting input mo, then this should output 1. So the question is, ano yung nasa inverting input mo na input? It's simply the ground. And kapag ground, anong voltage nun? The voltage is of course equal to 0 volts. So meaning, if your V plus is greater than 0 volts, or in other words, positive siya, tulad nitong mounting na to, okay, yung output mo ngayon is equal to VCC 1 volts. So from this point up to this point, ang iyong output is simply the VCC itself. Pagdating mo dito, pupunta na siya sa negative. Okay? And so kapag negative siya, it is now lesser than the 0 volts na nandun sa ating inverting input. So this will now move back to the 0 volts. And just like that, mag-uulit to. So now what you have here is from an analog system like this, naging digital system na siya like that. Composed of yung VCC mo, or yung pinaka-positive voltage mo, and your 0 volts. Okay? So after nyan, syempre, ang gagawin mo na dyan is i-convert mo siya into analog. Okay? And there are multiple ways of doing that. So kapag nabasa mo kay Boylestad, isa sa mga ginagawa nila is yung ladder network, no? Eto hindi na natin ito hindi ko syempre papalalain pa, no? Pero ganito yung itsura ng isang ladder network, no? So isang resistor na pa ganito, okay? Dalawa sila, okay? And ang value nitong dalawa is 2R. Then you put an R here, and then another 2R here, and then an R, okay? And then dadagdagan mo lang, okay? Basically, sa per part na to, nandito yung iyong digital input, and then this is connected to ground, okay? So dito sa part na to, yung iyong analog output, okay? So hindi nyo na kailangan ano yan. I feel like na mali ko rin yung drawing nito, so apologies for that kung nabasa nyo na yung kay Boylestad. Pero basically, ganito yung pinaka-idea ng pag-convert mo from digital to analog. Pwede rin another ways of doing that sa may mga circuit side din. Yun yung i-discuss natin sa later lessons. For now, dito muna tayo sa basics. So of course, with any number systems, ano bang ginagawa natin sa numbers? Usually, nag-operate tayo in between them. Ina-add natin sila, minumultiply, and then sinasubtract. Minsan, dinidivide. Pero for now, let's actually discuss yung pinakatatlong main operations pagdating sa binary numbers. Si addition, subtraction, and si multiplication. So first, let us have some numbers, no? Let's say gusto nating i-add si 1. Okay, ganito lang muna, no? Siguro gawin natin is maghanap tayo ng dalawang decimal numbers and let's add them. Ayan. Ayan. It's 24. Tapos, 12 times 12. Ayan. Okay. So, we have 3 different decimal numbers na kailangan natin i-operate sa kanilang dalawa. Okay. So, kapag nag-add tayo nito, obviously, the simplest way of doing this is kapag in-add mo lang sila. Simply, 80 lang to, right? Okay. 30 minus 24, 6. Okay. 12 times 12, 144. Very good. Pero paano ngayon kapag naka-decimal, naka-binary sila? So, let us actually try and see kung tama yung makukuha nating sagot. Kasi remember, kapag tama yung pag-add, subtract, and multiply mo sa binary, lalabas rin yung tamang sagot sa decimal niya. So, let's start with something like 57 plus 23. So, kapag kinonvert natin si 57 to binary, anong magiging equivalent niyan? So, ganito. Remember, sa binary, first it starts off with 1. Okay? And then may isa pang digit yan. Okay? So, for each digit, nag-i-increase siya or nag-multiply siya rather by 2. So, for example, dito, you have 1. And then dito magiging 2. And then 4. And then 8. And then 16. And then 32. So the question is, paano tayo makakakuha ng 57? So, pwede natin si 32 i-add kay 16. So, that will become 48. So, ano na ang need natin? A 9 and a 1. Or rather, a 9 lang pala. We need 9 para makuha si 57. So we can have 1 here. And para makakuha tayo ng 9, pwede natin ilagay si 8 and si 1. So ito na yung pinaka-representation natin kay 57. 1, 1, 1, 0, 0, 1. Okay, so again, let me explain. Kapag kasi for example, nakakuha ka ng 32, right? I-minus mo na siya agad kay 57. And you get 25. So, once na nakuha mo na 25, you minus the next number to that, 16, para makuha mo naman yung next number to that. So, for every time na nakakapag-subtract ka ng highest number, nakikita mo na may natitira pa, you mark that with 1. So, for example, si 9. Ano bang next number na after ni 16? Si 8. So, you minus that by 8 and you get 1. So, you put 1 kay 8. But then, yung 1 natin na natitira para maging 0 is nandito na sa 1. Si 1 na nasa pinakauna. So, ilalagyan mo na lang ng 1, yung pinakaunang digit, and the rest ng hindi mo ginamit, you put zeros. Kaya ito yung kay 23. So, with that, we can say that kay 23, no, kay 23, it is simply si 16, okay? So, si 16, makakakuha tayo ng 7. So, obviously, we can't use 8. So, we have to put 0 on 8. But then, we can use 4. So, minus 4, and we got 3. So, pwede natin gamitin yan. Then, we can also use 2. And then 1. So, now, we have the two numbers expressed in binary. Question now is how do you add? Okay. The way you add here is simple. C1, pag in-add mo kay 0 of... Okay, let's start with the basics. 1 plus 1, or 0 pala rather. 1 plus 0 is equal to 1. And then 0 plus 0 is equal to 0. Okay? But what about 1 plus 1? Si 1 plus 1, dapat 2 siya. But since binary tayo, it is instead 1 and then 0. So, itong 1 na to, siya yung iyong carry. Okay? Para na yung pag nag-add ka ng, for example, 19 plus 22. Alam naman natin 9 plus 2 is 11. But in this na ilalagay mo si 1 dito, you let it be carried to the top. Kaya magiging 41 ngayon yung sagot dito. So, ganito rin yung gagawin mo dito. So, with that, for example, number 1, or rather sa addition, 1 plus 1 is supposed to be 2. Okay? Or 1, 0. But since itong 1 na to, okay, sa second digit na siya, we will let it be carried dun sa taas. So now, si 1, ilalagay natin sa taas. Now, 1 plus 1 is still 1, 0. And again, dahil may 1 ka dito, you let it be carried to the top. So 1 plus 1 here is again 0 ulit, and then 1. So 1 plus 1 is another 0 to the 1. Now, meron ka ng ganito. 1 plus 1 plus 1. 1 plus 1 plus 1 is equal to 3, which is equal to 1, 1. So, you simply put 1, 1 here, and ito ngayong 1 na to, i-carry mo siya dyan. Okay? So, you got 1 plus 1, which is 1, 0. So, yan na daw yung sagot mo in binary. So, para ma-check natin, ano ba tong place na to? 1, 2, 4, 8, 16. 16, 16, 32, and then 64. So, 64 plus 16 is equal to 80. Okay? So, at least, alam na natin kung paano mag-add in binary. So, paano naman kapag magsusubtract na tayo? Okay, sige, try natin. So, 30 minus 24. So, again, paano natin kinonvert kanina si si 30 or rather si 5723, ganoon din yung gagawin natin dito. So, I can tell na meron siyang 16, meron din siyang 8, and I'm pretty sure meron din siyang 4. 16, 8, 24. Yes, 16, 8, 4, and then 2. So, wala siyang 1. So, 2 plus 4 plus 8 plus 16. Ayan, okay. So, yun yung 30. So how about kay 24? I'm pretty sure may 16 and 8 lang siya. So wala siya nitong dalawang to. Okay, napaka-straightforward ng pag-subtract nito, no? So, it's like 0 lang to, 1, 1, 0, 0. Kasi same lang din naman yung nangyayari dyan, right? Okay, so what about kapag ang nangyari is ganito, imbis na, ay, bay natin ang onti ito. Okay, this becomes 1, 0, 1, 1, and then 0, and this becomes 1, 0, wait lang. Dito na pala natin nilagay yan. Ayan. One. Okay, ayan. How about this one? So this, nakita natin meron tayong mga 0, minus 1 dito. So what do we do kapag ganun yung nangyari? Simple lang naman, ang gagawin mo lang is hihiram ka dito sa katabi niyang number. So this will become 0 and this will become 1, 0. So 1, 0 minus 1 is equal to 1. Kasi nga, this is not 10. This is 2 minus 1. Alright? So, 1, 0 minus 1 is equal to 1. So this one will become 0 minus 0, which is 0. And then 1 minus 1 is 0. And then ito na naman, nangyari ulit siya, right? So 1 and then 0. 1, 0 minus 1 is another 1. Okay? So the answer is 1, 0, 0, 1. So paano natin ma-check? Okay. 1, 2, 4. So this is 4, 8, 16. So this is actually the number 20. Ma-minus ko daw siya kay 1, 2, 4, 8. So 4 plus 8 is 12 plus 1, that is 13. So this is 7. So we have 1, 2, 4, wait. Sorry, wait lang. Parang namali ako. Wait lang. 1, 2, 4, 8. So 8 plus 4 is 12 plus 1, 13. Okay, tama. So this one, 1, 2, 4, 4, 8, 16, 20. So 20 minus 13 is 7. Okay, so gawin natin ulit yung pag-subtract nito na mali yata ng pag-subtract. Isa pa. 0, tsaka na to? 1. Okay, isa pa. So, again, 1, 0 minus 1, so that is 1. Okay, this one will become 0. So, simply 0 minus 0. Okay, so that is 0. 1 minus 1 is 0. And then 1, 0 minus 1, that is 1. Okay, 1, 0, 0, 1. So this will become 9. Question is, tama ba na pagkaka-convert kanina dito? Kasi I'm pretty sure mali ako doon. So 20. Oh, wait. Nakalimutan ko pala na ano. Oh, okay. There you go. May 2 pala to. So, my apologies. May 2 pala to. 1 to eh. Right? Okay. So, this was actually 2. So, 2 plus 4 plus 16 is actually 22. Ah, okay. Ayan. Naano ako doon. Na-triple ako na konti doon. Okay. So, 22 minus 13 is equal to 9 pala. Kasi kanina pala 1 pala. Naging 0 siya kasi nag-borrow tayo. Okay. So, my apologies for that. Pero, nag-gets nyo naman yung pinaka-process niya. Okay? So, ganun yung mangyayari kapag subtraction. So, what about kapag multiplication na tayo? So, the multiplication is just the same way kapag gumagamit ka ng, or rather, nag-multiply ka sa decimals, right? So, when you put 12, we have 1, 1, 0, 0, and you multiply that by 1, 1, 0, 0. Simply, multiply mo lang ito. Alright? It's like, hindi siya complicated. It's 1 to 1, supposedly, ganun, di ba? Okay, hindi. Siyempre, hindi yung 1 to 1. Okay? Pero, the way this works is simply, so 0, 0, 0, 0. So, you have 4 cases of zeros and a 0, 0, 1, 1 on the others. Okay? So you have 0, 0, 0, 0, 0, and you can see here na 1, 2, 3, 4. Oh, okay, di pala 0 yet. Okay. So you have 4 zeros dito. Ganun din kadami yung zero sa dulo. So ang matitira na sa is 1 to 1. So paano mo ba kino-convert si 1 to 1 into binary? Usually mahaba pa yun. Pero ang inaano ko ngayon dito is yung kanyang BCD or binary coded decimal. Alright? So what I'm saying here is that you will represent 1 to 1 for each digit as binary. So si 1 to 1 can be expressed as 1, 1, 0, 1. So kapag, or rather, of course, kasi may 2 ka dito eh. So basically, 1, 0 siya, di ba? 1, 0. Ay, hindi pala 1, 2. Ito, isa pa. Okay, binary coded decimal niya. So basically, 1 to, etong 2, 1, 0 siya. Pero yung 1 na to, ika-carry mo siya sa 1 na taas. So you got 1, 0, 0, 1. So definitely 1, 0, 0, 1. Okay? Or in other words, in-add mo lang ito. Okay, basically 0 plus 1 plus 0 is 1. 1 plus 1 is 0 na may carry 1. 1 plus 1 is 0 na may 1 sa unahan. So, yan ngayon yung pag-multiply using binary. Okay? Now, of course, kapag tapos ka na dyan sa pag-operate in binary, discover ka na ng isang different na number system. So now, all you have to do is learn the other number systems na meron tayo. Okay? So, of course, alam naman natin na familiar na tayo with the base 10 number system, aka the decimal. Familiar na rin tayo with the binary system. So, how about itong octal and hexadecimal? So, ang pinagkaiba lang nila is that pag octal, that is base 8. And kapag hexadecimal, that is base 16. That's why it's made up of 16 digits. Okay? So, yung ano dito, operation nila, no? Usually, let's actually convert, for example, yung isang number. Let's say, meron kang isang number. 3, 4, 5. And you wanna convert that to octal and then to hex. So, paano mo i-convert from binary to octal, or rather from decimal to octal, and then to hex? Okay, so the simplest way of doing this is i-convert mo muna siya into binary. Okay, pero alam naman natin na siyempre malaki tong number na to na 3, 4, 5. So, what is the simplest, or rather a simpler way of doing this? So, the simpler way of doing this, okay, is to okay, so the simpler way of doing this, okay, is you have to convert this muna using some sort of algorithm, no? So usually may algorithm tayo pagdating sa mga conversion to other numerical numbers. Most of them, well, actually madami talaga sa nila, it involves converting to binary. Pero sometimes, meron yung ano na, diretso na. Okay? So, paano yung pinaka-diretso nito? Ganito yan. For example, you wanna convert to octal. Itong gagawin mo muna. Si 345, i-divide mo siya kay 8. Okay? So, anong need mong kunin dito? Wait lang. Okay. So, kapag dinivide mo si 345 kay 8, you need to find the integer part and the remainder. Okay? So, you have a 43 sa decimal, sa integer nito, and yung pinaka-remainder niya is 1. So, check lang natin. Ayan. So, ano nang mangyayari? Etong remainder 1 na to, siya yung pinakauna mong digit. Okay? So, your A1 is equal to 1. So, what's next? Si 43 ngayon na integer, i-divide mo siya ulit kay 8. And the same process pa rin. So you have 5 here and 3 here. So your A2 is equal to 3. So si 5 ngayon, pag dinivide mo siya kay 8, alam natin na wala na siyang integer, pero yung 5 yung kanyang remainder. So your A3 is equal to 5. So that means 3, 4, 5 in decimal is equal to 1, 3, 5 in hex. Okay? And meron tong, meron siyang way na magawa mo yung calculator to. So it's actually 3, 4, 5 and then shift base convert to octal. Ayan. May ganun siya. Okay? 345 tapos base. May nakalimutan. Okay. 345 and then meron siya dito yung octal. Okay, so naka-base N ka pala muna. Ayan. And then you do octal. Ayan, tama. 531 pala. My bad. 531. Nagulat rin ng 135 eh. 531 pala. Okay. So, ito pala yung tama, ito yung pinaka-last digit mo. So, ito yung pinaka-unang digit mo. Yung pinaka-unang digit mo sa right. Okay? So, 531 siya in octal. Here's another example. What about kapag mixed numbers na siya? Okay? Let's say you wanna convert 80.179 from octal from decimal pala rather. So, ayan. And you want to convert that to a base 8 number. So, what do you do? So, itong gagawin mo. Gawin natin 83 para mas mahirap siya ng konti, no? Okay. So, itong gagawin mo. Tawag dito, hiwalayin mo sila into yung kanyang integer part and then yung kanyang tawag dun, decimal part. So, what I mean is, hiwalay mo siya into 83 and kay 0.179. Kasi hiwalay kayo ng gagawin dito sa dalawa. Okay. Start tayo with 83. I feel like mahaba tong 0.179. Kaya start tayo kay 83. So, madali na to si 83. The same way na ginawa natin kanina. 83 divided by 8. So, yeah, 10 and 3. 10 divided by 8, which is 1 and then 2. And 2 divided by 8, which is equals to 0 and 2. 2. Okay, yan. So, now we have 2, 2, 3. Okay, yan yung 83 mo. But what about 0.179? So, kung ano yung ginawa mo dito, baliktad yung gagawin mo. Imbis na i-divide mo siya kay 8, si 0.179, i-multiply mo kay 8. And so, you get 1.432, di ba? So, yung 1 ngayon, siya yung iyong integer part, okay? And yung decimal part mo is si 0.432. So, si 0.432 na ngayon, i-multiply mo siya kay 8 ulit. So, you get 3.456. So, 3 and then 0.45 and then 6. Ulit-ulit tayo dito. Tama. Tama. Okay. So, anong pinaka-goal mo dito? The goal here is that dapat yung decimal mo, wala na siya. As in, magiging 0 siya. Okay? So, for example, si 0.456, minultiply pa natin kay 8. This is gonna be a bit long. So, ayan. 0.648. So, hindi ko lang kung mag-end pa to. Okay? O sige, hanggang dito na lang. 5 and then 0.184. I think, ito na talaga. Ito na talaga. Ayan. Damn it, hindi na siya nag-end. O sige, ganito na lang. Okay. So, yan na yan. 1335 and then ano yung next one? O yan, hanggang dyan na lang. Alright? So, the final way of expressing 83.179 from decimal to hex is simply 223.13351 ... Okay, paulit-ulit na siya. So, ito ngayon yung kanyang representation in hex. And I have a very good exercise for that. Na-prepare na pala yung exercise ko dito. from converting from decimal to octal to hex to binary, etc. No? So, gawin natin right now, mamaya. Pero wait lang. Okay. So, syempre, again, pwede nyo siyang ma-check sa inyong calculator, no? Meron niyang tutorial online how to do it. Hindi ko na papakita, no? Kasi, tawag dito. Ewan ko bakit ayaw ng calculator ko, honestly. Okay. So, ito lang, here's a note for this one, though. A note, wait. Ang note ko lang about this one is that hindi mo pwedeng, by the way, one pala dapat daw to. Okay. Wait lang. No, that's correct. Okay, ayan. Okay. So, here's a note about this. Etong mga decimal, hindi kaya ng kaso niyan. So, hindi kaya ng calculator yan. Or at least ayun yung pagkakatingin ko kasi hindi niya talaga nagagawa yun sa akin. So, kung kaya ng calculator nyo, ayan, pag nilalagay ko yung dot sa base and hindi nagpapakita si dot. So, hindi nyo ma-check to. But you can check the decimal. That's why na ano, kasi nakalagay dito, it's actually 1, 2, 3. So, sandali lang. Okay. Ah, okay. Ay, very, very creepy. Okay, my bad. So, yun, tama nga pala to. Okay, ayan. So, nakorek ko na. 1, 2, 3 nga yung 83. So, my bad. Pero, naano ko kanina, hindi eh. Okay. So, weird. Okay, anyway, so, ayan. So, basically, yan yung pag-convert from a decimal to an octal. So, how about, say, from decimal to hex? Or, well, okay, try na. Yung same rin ng pag-convert doon. So, for example, kapag gusto mo na siya i-convert to hex, okay, sige, kuha tayo na example dito sa, hanap tayo ng madaling tanong. Sige, ito na lang pala. Gawin na lang natin to. Okay. Ang gusto kong gawin natin is let us convert itong binary muna to hex. Kasi hindi natin napakita. Okay. So the question now is how do you convert from this binary to the hexadecimal? Ito ang pinaka-simplest way. Paano mo kino-convert palagi si binary to any other number systems? Yun yung pinaka-madaling way. For example, kung gusto mo siya i-convert to hex, ang gagawin mo lang is i-group mo ito by 4s. So for etong ano na to, i-group mo sila by 4. Okay? So you have 1, 1, 1, 1. Okay? And then 1, 0, 1. But since kailangan apat sila, lalagyan ko na lang ng 0 sa simula. Point 1, 0, 1, 0. Okay. So now na na-convert mo na siya to 4 digits, what is next? What's next is for each 4 bits na to, ko-convert mo siya into hex. And kung naaalala nyo dito, okay, we have a total of 16 digits. So let's actually, for example, itong 1111 na to. So 1111 is simply the very last digit, si F. So you have F here. 0101 is what? So this is 1 to 4. So 4. 1 plus 4 is 5. Meaning, ito yung pinaka-fifth digit which is we know as 5 lang. So we have 5F point 1010. So 1 here is 1, 2, 4, 8. 2, that is 10, and the 10th digit is 9. So we have 5F.9. So yan yung ano. And again, yan yung tamang sagot. So ang pinaka check mo nga lang dito is yung whole number niya, 5F. So pwede nyo again siyang i-check sa inyong mga calculators. Try ko, 10111111. Alright. And then, I go to hex. Ayan, 5F ka. Ayan, tama na siya. Okay. So, si 5F si hex. So, ang problem mo na lang, of course, si 1010. So, si 1010, kapag kinonvert ko siya to hex, A pala. A, hindi 9. My bad. A pala. Okay. So, ito pala yung 9th digit. Ay, my bad. Ayan. 10th digit. Ito yung 10th digit. So, na rin ako. 1, 2, 3. Okay. Kasi 0 nga pala yung pinakaunang digit. Okay. So, 5F.A. Remember, this is your 10th digit kasi si F mo is your 15th digit. No? So, doon na medyo nalilito rin kapag hexadecimal. Okay? So, alam na natin, of course, that the answer to this one is 5F.A. Now, question, paano ko ngayon i-convert si binary to octal? Mahirap ba yung process? Hindi. Kasi remember, sa octal, you have 8 digits. 8 digits meaning, that's right, ikaw ay mag-group lang ng tatlo na ganito, di ba? Kasi, okay, mag-group ka lang ng tatlong bits. Okay, bakit? Kasi remember, this is 1, 2, 4. 4 plus 2 plus 1 is equal to 7. Now, i-consider mo rin yung 0, 0, 0 na possibility. So, you have another one which is 8. Okay? So, in short, para i-convert mo yung binary into octal, you group it into 3 instead. So, you have 101 here sa decimal, and then 111 na una, and then 110 na pangalawa, or 011 rather, and then yung pangatlo na 100, 001. Okay. And then, convert mo na lahat yan into octal digits. So, you have 001, which is 1, 011, which is 3. 3 ba to? Sandali lang. 1, 2. Oh, tama, 3. And then 111, which is, of course, 7. So, 137 point, what is 101? 1, 2, 4, 5. 5 nyo. So, this is simply 137.5 na base 8. So, check natin ngayon yung 1011 natin. 101111. Here you go. Convert to octal. 137. Ayan. So, very good. We have 137.5. Okay? So, yan yung octal niya. Okay. Now, paano na kapag pag dinesimal? The same way na ginawa natin kanina, kaya naman to ng inyong calculator. Ano ba nakalagay dito? 95 point. So, yung 101 natin is simply 101 is 101? Hindi Wait lang. 5. 95.5. I'm pretty sure isa siyang radio station. Okay. So now, yan ngayon yung pag-convert from binary to any other number systems. So, let's say, binigyan ka nila ng octal na 483.58 and you want to convert that to decimal or to binary. So, madali lang to i-convert to decimal kasi ang gagawin mo lang, for each of the digits, you will multiply it by 8 raised to n minus 1. What does that mean? Ba't ako nagsasabi ng ganon? Okay, for example, si 4. Si 4 mo is the third digit to the left of the decimal point. So, si 4 ngayon, ang mangyayari, you will have to multiply that by 8 times 3 minus 1. Okay? Ayan yun. What's next? Si 8 ngayon. You will multiply that by 8. Okay, wait lang. Wala nga palang 8 na. Wait lang, 7 lang natin to. Sorry. Wala nga palang 8 si octal. Okay. So si 7, imo-multiply mo siya sa 8 raised to 2 minus 1. And then si 3, imo-multiply mo siya kay 8 raised to 1 minus 1. See? So para lang siyang yung sinabi ko kanina na kung ano yung pinaka digit place niya. You minus that by 1. So what about si 5? Si 5 ngayon, syempre, ito yung nasa what? Right side. Okay? So, syempre, ang mangyayari dyan, it's going to be 8 raised to negative 1 kasi siya yung pinakaunang digit sa right side ni decimal. So, which means that the next number na 7, i-multiply mo siya kay 8 raised to negative 2. Okay, and then you add simply lahat yan, no? So, sandali lang. 4 times 8 squared. So at least, kapag pinahanap sa inyo ni sir yung pag-convert niyan, without using your calculators, alam nyo kung ano yung gagawin, no? Hindi yung matutulala lang tayo. Okay? So, wait lang. Okay, mabagal lang mag-calculator, but here we go. 315.73. Okay na yung 0.73. Okay, so yan ngayon yung conversion ng octal to decimal. Question. How about from octal to hex? Dun. Okay, so paano i-convert si octal to hex? So for example, si base 16, i-convert mo siya into base 8. So how does it work? Okay, the first thing to do is i-convert mo muna siya kay binary. Okay, so dito kanina sinasabi na hindi straightforward yung pag-convert from octal to hex. So between octal and hex, yun lang naman ang hindi straightforward. Yung between decimal to binary from other number systems, yun, straightforward na yun. Okay? Pero ito ngayon, dito, so anong gagawin mo dito? Okay. Si 473.57, you have to convert that to binary. Okay? So, matrabaho to. Okay? Pero, that's why meron tayong calculator. Okay. 473 na decimal, gawin natin binary. Okay. 111.011.001. Okay, point. Tapos yung 57 naman, 111.001. Okay, yan na yun. And then, same process na ginawa natin kanina. Okay? Remember, ginawa natin sa X. Group natin each bits into 4. That's the same way we're going to do it. So I'm gonna group these bits and then these bits into 4s, aka a nibble. Meron na akong nibbles. So I have 0, 0, 0, 1, 1, okay, wait lang. Okay, 1101, 1001.11100100. Okay, and then you convert that to your digits. So you have 1 here. Ito, 1101. So that is 8 plus 4 plus 1. That is 13. So what is the 13th digit? That is letter D. So delta. Right now, check lang natin. Okay, yung delta nga. So 1001, this is 9. Okay, so what about this one? 124, 824, which is 14? 14. So that is your letter E na lang. And of course, ito is 4. Okay? So, in short, ang pinaka 473.57 natin is 1D9.E4. And likewise, ito yung sagot sa pinaka-binary niya. Okay, ayan. And so, kapag alam niyo na kung paano mag-convert from octal to hex, okay, alam niyo na rin, syempre, from hex to octal. And then from hex to decimal. Ang pinakamadali dyan, of course, na gawin is from hex to decimal. Kasi, ang gagawin mo lang dyan, is imbis na times 8 squared, so for example, dito, ginawa natin kanina is 8 squared. This time, si f natin na 15, you'll multiply that by 16 naman squared. Okay? plus 2 times 16 plus 5 plus 1 times 16 raised to negative 1 plus 6 times 16 raised to negative 2. Okay, so kayo na mag-solve nan. Kayo na yung mag-convert ng iba. And so tapos na tayo sa mga different na number systems and kung paano mag-convert sa in-between number systems. So ang next lesson natin, okay, will be of course yung sa complements naman. So that is one of your introductory concepts, yung complements. Yung pag-add, okay? Yung pag-add, ganun rin siya, no? So for example, hindi ko naturo ng so gawin natin para. Sige. Kunyari, mag-add tayo ng 473 plus 58. 473 plus 58. 473 plus 57, pero naka-base 8 sila. Okay. 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 So, paano yung pag-add nito? So, the first thing you do is you simply write it. Okay. And then, how do you add it? So, yung ginawa natin sa binary, usually, ina-add natin, may carry siya. Pero kailan natin siya kine-carry? Kine-carry natin siya kapag umabot na siya ng 2. Di ba? Kung maaalala nyo dito, 1 plus 1, 2 na to. So, kine-carry na siya kapag 2 na siya. Di ba? In our case, yung 2 kasi natin, yan yung pinaka-base niya. So, with that said, yung pattern natin dito is that i-carry natin yung number kapag sumobra na siya sa base niya. So, for example, 7 plus 3 is 10. 10, which is 1, 0. Pero sumobra na to ng 8 eh. So, itong gagawin natin. I will subtract this by 8 and ang matitira na lang dito is 2. So, yung 8 na yon magiging 1 na siya dito sa taas. Okay? Kasi remember, each carry na 1 is equal to an 8. Okay? So with that, kapag in-add ko to, this is 13. Minus natin ulit by 8, so you have 5. And dahil nag-minus ako ng 8, I will simply carry that 1 there. So we have 1 plus 4 and that is 5, 5, 2. Okay. So the question is, tama ba yung ginawa ko na to? Okay? So dito natin malalaman. Let's try it out. 473 plus 57. Oh my God, tama. Okay, very good. So ayan, tama siya. Wow, kinabahan ako ng onte kasi akala ko hindi siya tatama. But there you go, tumama siya. Okay. So, ganun yung pinaka-process niya. You simply carry it. Let's try a hex number. F25. Base 16 siya, syempre. So, let's add it to hirap mag-isip ng number. 9 FE. BE. Okay, 9BE. Okay, ayan. So, okay, 9BE. Okay, add natin. Nakakasawa makakita ng blue. So, gawin natin. Ibayin natin yung ating pen color. Alright, okay. So si F25, i-add natin kay 9B and then E. Okay? And again, the same concept follows. Kapag sumobra siya ng 16, we take it out. Or rather, we carry isa. Okay? Okay. So, yung E natin, of course, this is 14. 14 to. And yung 5 natin is 5. So, 14 plus 5 is 19. But since sobra siya ng 16, I will carry 1 here and subtract 16 kay 19. So, I get 3. Okay? Now, B is what? From 9th digit yon, then 10 is a... Okay, 11 to. 11 plus 2 plus 1. So, 11, 12, 13, 14. So, you have 14. Now, hindi siya sumobra ng 16, pero ang 14, in hex is actually letter E. Okay? So f plus 9, which is 15 plus 9, is equal to 24. So this will become greater than 16. So minus natin na 16 and we get 8. So we have 8 here and nag-carry tayo ng isa dito, meaning ang final answer natin is 18E3. So, tingnan natin kung tama. F5 plus 9 BE. Okay. Okay. But ayaw niya okay. Kasi naka-octal. Okay. Hex. Okay. 18E3. Okay. Yan. Tama yung sagot natin. Alright. So, yun yung pag-add in other number systems. And again, ganun rin siya mag-minus. Kailangan ko pa ba ipakita? Sige na, ipakita na natin. Okay. Sige, kunin natin yung 18E3 and isosubtract natin siya kay F25. Okay, 3. Si 3 natin is lesser than 5. So we can't just subtract that. So ang gawin natin, babaro tayo ng 1 kay E. Pero, ito mangyayari, imbis na idadagdag natin dito is 10 or 2, we add that by 16. So this becomes 19. 19 minus 5 is 14, which is letter E. So now E here becomes letter D, which is of course equal to 13. 13 minus 2 is 11, and the 11th digit is letter B. 8 minus F, since yung F natin is 15, we can't simply subtract that. So, babaro tayo ng 1. We have 18, 24. So, 24 minus 15 is 9. So, as you can see, nakuha natin yung ating 9BE from subtraction. Okay? And, ano pa? So, yung pag-multiply, sige na, gawin na nga rin natin yung multiply. F25, i-multiply natin kay 3F. Siguro okay na to. Okay. So, this is ano? Okay, so ito medyo hindi straightforward, no? Pero ang ano dito is, kung yung ginawa natin dito, minultiply natin, syempre sila. Dito, same lang rin. Ano ng problem? This is F. So this is 15, right? So you have to multiply 15 by 5 to get 75, and then idadagdag mo pa si 7 doon. So si 15 times 2 is 30, plus 7, so 7, and then 3, 15 plus 15, times 15, and malaking number siya. So in short, sana, diniretso mo na muna into decimal bago mo sila i-multiply. Alright? Pero yun naman palagi yung nangyayari doon. No? Parang yung ginawa natin sa binary kanina. Actually, pwede mo siyang idiretso to decimal and then i-multiply mo sila in decimal. Pero ang ano kasi dito is you need to convert this into hex. You need to convert that into hex. Okay? So, pero, same lang sila ng concept. Mas matrabaho lang to gawin. Okay? So, yun yung pinaka main lesson natin for today. And so, in the next lesson, we'll be talking about complements. As in, bakit merong complements and all of that. So, to recap, pinag-usapan natin about digital systems and why it is easier to work with digital systems. Again, digital systems consider only discrete amounts of data, aka a fixed number of them in one storage. Okay? It is easier to work with kasi it represents discrete amount of possible states. For example, if you are binary, you are considering only the possibility na may off or on. It is also possible to tolerate noise kapag kinonvert mo siya into, for example, itong binary system because you are simply evaluating it as either off and then on. It is now easier to convert that digital signal into an analog signal kaysa gamitin natin yung analog signal na noisy continuously. It is also easier to transmit data by zeros and ones, and it is also easy to build binary circuits. And we also have discussed mainly the binary system and yung operation of binary system and how we could relate that one to the other number systems, which is the common decimal number natin na base 10, yung panibagong octal na base 8, and yung hexadecimal na 16 digits. Ang pinaka-significance nitong dalawang to is in computers. You will see that there are some, for example, yung ating hexadecimal color system, you will see na meron siyang group of 6 letters or 6 possible digits. Meaning, you can represent colors based sa kanilang shade and etc. using simply yung hexadecimal na numbers. It is now easier to express different colors through hexadecimal numbers. And with that, that concludes the first lesson for today.